I was commuting myself here today. So what I want to do today are two things. Actually, so are there volunteers that want to ask questions about the project? There were last time. So would you like to have a bit of time today? Let's try at least. You know, you propose some interesting questions, and I try to help, and the audience tries to help. Okay. Okay. So we will do that towards the end. The first part that I want to do is some clarifications on threads and processes that actually came out of a discussion I had with a student. You know, he asked the very interesting questions at office hours, and I thought I should cover these the explanations in class. And then I want to talk about databases a little bit. Okay, so these are the two things I plan to do. It's quite works, man. Okay. So the discussion is prompted by the fact that now that we do services, we have a sort of wider view of the various combination of threads and software containers in Android. So I just wanted to give you a picture like this. When you build an app, it looks a little bit like this. So this is your app, and inside of the app, you typically have one or more, I'll draw a couple of them, okay, of activities. So this is activity 1, let's say, and this may be activity 2, okay? So when you write a very simple app, what happens is this, okay? So the app defines essentially a process, okay? So these activity 1 and activity 2 are in the same namespace, essentially. They can if you had a reference from one to the other, which you typically don't, but you could call methods one of the other, okay? Or if you define, for example, some static final, you know, these constants essentially, but sort of static final variables here, you could refer to them from there, okay? So this is essentially the same namespace, okay? If you do very simple things, the way, such as, you know, you draw some UI and you ask the user some questions and you direct them from one thread to the other, then you have only these activities are executed in the UI thread. Okay, so there is the UI thread, and whenever essentially some UI event happens, so whenever the activities are created, you execute the onCreate, onStart, onResume method in the UI thread. And whenever there is some UI event, such as, you know, a user presses on a button, and the button you define the on-click listener, the on-click event will be processed again in the UI thread of these activities. Okay. Each one of these activities, you define a class, obviously, to define the behavior, and they are instantiated into objects. Okay. So when the application is started for you by Android, let's say that for activity 1 you defined a launch method, a launch broadcast receiver. You know, in the manifest you say that this can receive the action intent launch, essentially. So this can be launched and has an icon on the home screen, okay? And when the activity 1 is launched, out of this class, Android instantiates an object, okay? So any class variables in the activity will be any variables that you define as, you know, private integer x and whatever else here, let me say, for example, private integer x, okay, this is an object variable associated with this activity, okay? So you have to be a little bit careful, because in some instances you are actually able to have multiple copies of the same activity on the stack that are actually corresponding to different objects, okay? This can happen, for example, if from activity 1 you can start activity 2, okay? You have 2 ways of going back from activity, 3 ways at least of going back from activity 2 to activity 1. And let's look at them a moment and their effect on the stack, okay? So at the beginning we have activity 1 only. Then once you start this via an intent, the intent is defined, you know, as intent I is equal to new intent, and it will say something activity1.this, comma, activity2.class. No? So it's an intent that will wake up this activity. So once you do that, you have 3 alternatives to finish this. One is to say finish. Okay, so this will essentially say, alert Android that you have done and that you want this to be unwrapped. So when you say finish, what happens is that you signal the OS that you want to finish, and then you will go through your on pause, on stop, and on destroy methods. Okay, so you do in the opposite direction essentially the three methods that correspond to an activation. Okay, so if you activate activity 2 with the intent, once you execute finish, this is removed from the stack, and you're back at activity 1 on top of the stack. Okay, that's a perfectly fine way of stopping processing in an activity. Okay, it essentially says I'm done, and just give back the control to the old top of the stack, activity stack, whatever that is. Now, one point that is interesting, and I should mention it now, is this. Android reclaims activity objects when it likes. So it typically tries not to reclaim the one on top of the stack, because that's what, governing the UI that is in front of the user. But anything that is below that, if it runs low on space, or if it feels like essentially running low on space is the typical case, right? It might reclaim it. So it might be that you have an activity 2, and that the object corresponding to activity 1 is actually removed from under your feet. Okay? So you can still execute on finish, and Android will remember that the activity 1 used to be the top of the stack. And what happens is that when you go back to activity 1, a new object will be created, and so the onCreate, onStart, and onResume method will be executed, right? The difference is that if activity 1 was not removed, if the object was not, removed by Android, then the onCreate method would not be executed again when you execute on finish of activity 2, okay? Because the object is already created. On the other hand, onStart and onResume would be executed, okay? All clear so far? Eh? Okay. Now, another thing you can do from activity 2, another perfectly good way to finish, is to create an intent. Let me simply indicate it in this way. It's an intent to go to activity 1. It's just a symmetrical depend from activity 1 to activity 2. You can create the symmetrical. Now, and this you say add flag clear. I think the name is clear cop. I think I told you it before, but essentially this means that you want only one copy of activity 1 on the stack. Okay, so this means that if you are in this condition, again, activity 2 will be removed from the top of the stack because there is a copy of activity 1 below, and the same object, if it hasn't been deallocated, will execute. So in this case, finish and this alternative 2 are synonyms, but they are not in general, right? Because they mean the same thing, only if the only way in which you can get to activity 2 is through activity 1. If there was some other way to get to activity 2, then this essentially finish will just remove activity 2 from the top of the stack. And instead, 2 will force you to jump to activity 1, removing anything above the stack. Okay. So these are the two differences between these two methods. Okay, there is a third method, okay, which is not really recommended. So maybe I indicate it with a cross, which is simply that from activity 2 you can start activity 1. But if you do this, what happens is that you create another copy of activity 1. Oh, I mean, you get a new object for activity 1. Okay, this might be useful in some situations. Okay. For example, I don't know, I'm composing an email, and then, I do a web search, and from the web search, there is I go, I don't know, to a shopping site, and there is a link to contact them. I click on the link to contact them, and, I get to another copy of the compose activity, but, I may have 2 copies of the compose activity, and so, once I compose the message in one activity, then I can go back and if I can finish composing the message to my friend instead. So I mean, it's not always bad to have two objects belonging to the same activity on the stack. It's your choice, essentially. Okay. Now, slightly more, you know, some other complication. I mean, not complication, but some other features. I told you at the beginning of the class, I don't remember which lecture it was, but I gave you some methods to do inter-thread communication, inter-activity communication. So how do you share information between activities? So there were various ways. One way was to attach information to indents, okay, that would be carried from one to the other. This is possible. It's usually, you know, limited to. It's like I would say it's like a message. You know, it's something related to the action that you want to the other activity to carry out, right? You wouldn't do that for like system settings and things like that. That actually are stuff that needs to be read and written, but it's not like a message to be done. So if you have things that instead need to be like shared, but not explicitly passed like in a message, one approach is to use, you know, the system the preference settings, as I'm sure you know now. This sort of, you know, hash dictionary that is written to the flashcard. I think you all know by this point, right? You do? Yes. Another point that I mentioned is this, that you can create a singleton object. Okay, so you can create a class here in the middle. Essentially, it's a class appinfo. Okay, and then you make it initialize a method private, and you say you define a method that is called sort of I don't know, get it. I don't know. I mean, you can come up with a better name. I usually can come up with a better name. But essentially, this is a class method, a static method get it, okay? And so the way it works is this. Here you have a static variable that says instance. And you say, if instance is null, this means that no instance of this class has been created. So I create an object, I put it into instance, and I pass it back, okay? If instead there is already an instance, so if there is already an object of this class, I pass it back in instance. Okay. So I'm going fast on this code, but do you remember it, or would you like me to show it to you again at in some way? Or I can write it on the board. I think I can write it here. It's only that, you know, when I write in this way, sometimes I make mistakes, but assume that I don't do. Okay. You can correct me actually. Class of info, okay, and so so actually semicolon, or I don't know, I don't remember that. Those are the things I forget, okay. But then you say static get instance. Okay, it's static appinfo, sorry, appinfo get instance, okay, and you say, oh, sorry, here I forgot to say static appinfo instance is equal to null, for instance, okay, I don't think it's necessary, okay, but when you say get instance, what you say is so if instance is equal to null, no? So if there is no instance yet, you say instance is equal to new appinfo, okay, and then you say return instance. Actually, yeah, you can sort of collapse the code into okay, so just to save as you do. Okay, something like this. I mean, I may have made some you know, typo, but this is a concept. So you avoid creating more than one object. So, you know, where does that object live? Well, it lives in this process, right? So when this process is running, you may have an activity object, you have this object, and you have that object. And now, you know, a peculiar thing happens. These objects have been created by the UI thread, essentially by Android that is managing the UI, you know, and the intent interaction. So these are created for you, okay? These one you created yourself. These ones can be reclaimed. These ones, in general, is not. So this object actually will gonna stay unless Android decides that your whole process is gonna be reclaimed. This can happen, you know. Android never promises to let you run forever. Okay, so if you put too much stuff here, what might happen is that you know the whole thing is removed from under your feet. Why are we, I'm curious. So what's yeah, I mean, this is one of the difficulties. In fact, let me mention that, this is, I think, one of the typical causes of crashes in apps, and as well in my apps. And let me try to describe to you a typical way in which I've made you know these crashes in the past that are horribly difficult to debug. Let me see, so let me think a moment. Yeah. I cannot find an easy, super easy example, but let me tell you. Let me give you. Okay, no, I can find a simple example. Okay, let me tell you what is a typical way for me to break my work. Okay, and I think it's fairly common if I look at the complaints of other people in the App Store. You know, after a while you can read between the lines of what's happening, and a very typical way is this. Sharing via a singleton object is of course incredibly common because it gives you a very efficient way of having any sophisticated data structure, and you can just share it among all the components of your activity. So obviously a lot of people do it, and it's very standard. So let me tell you how. I think this I can erase because I think now you got the concept and you have the sample code. So let me tell you what I typically do. When I make mistakes. I mean, these are common. Must have done in a variation of these at least, a dozen times. So you start activity 1. Okay, activity 1 is where you start. There is no other place that can be launched in your application. Assume. Okay, it's the only place that other external places know. So you can only launch activity 1 from the main screen. You can only launch activity 1, and the other activities assume they cannot receive intents except at least once. Okay, so you are kind of sure in your mind that you start from activity 1. In activity 1, what you do is that you, let me just write it here informally, but you create an app-info, okay? You create an app-info object, and you init it with some special values, okay? Okay, this seems great. So what I mean by initted with special values is this. You don't just rely on the initializer method of app-info. But for example, you read, I don't know, you read the username and other things from the settings, and you're going to write it there, etc., etc. So that in the onCreate method of activity 1, you make sure that you really prepare this app-info object and you leave it in a good state. Okay? Now, what you do is that from this, you ask to go into activity 2. Okay, fine, perfect. Activity 2 starts. It starts using, the data in app-info, and it starts reading it to its own pleasure and doing whatever it wants. After this, the user switches off the phone and puts it in the pocket. Okay? While it's in activity 2, that maybe is doing something very minor and very silly. It's like, compose your message for somebody. One of these screens in which you're not supposed to linger for a lot. But the user instead, hey George, can't see this. Okay, and goes, then for the next hour, the user forgets all about your app. Okay? Then, so on top of activity 2, there is all kinds of stuff that happens. And Android, after a while, says, hey, look, this app is taking a lot of space, or is taking some space, hasn't been used in 1 hour, let's clean it out. Okay? And so everything is there located. Okay, not only the activity 1 and activity 2, but also the all the objects belonging to the process. Both. Now, what happens is this, that the user then pulls out the phone out of the pocket after 1 hour, maybe goes back from Gmail, it goes back, you know, to Chrome, and then goes back from Chrome, and you know, it eventually removes what's on top of the stack, and there is this on the top of the stack. Except that there is not this, there is the skeleton of this. A skeleton is not the right name, maybe the shell, you know, the empty shell. There is information that activity 2 was running, and so please bring it up again. Now, in the onCreate method of activity 2, you of course have this instruction that is also on top of activity 1. You typically have something that says info myinfo is equal to appinfo, get instance. No? This is what you do. No? Because you want to grab again the instance to the shared memory. And you do grab it. You grab it just fine. You know, it's created for you and it's given it to you. What's the only problem? That all this beautiful initialization that you did in activity 1 is not done for you. So, at least, you know, I've done this quite a few times. So, you now continue in activity 2, and you say, you know, I don't know, set text of, you know, and you use a string that you're supposed to have in appinfo. And what you get is a null pointer exception, because the string is null, because nobody set the string to anything. Okay? So, why is this so incredibly hard to debug? Because in order to debug it, in order to reproduce it, you would have to do the following. You would have to create activity 1, activity 2. Then you would have to somehow beg Android to please destroy the appinfo object. You know, you cannot do it in testing. You cannot do it if you test in real time, because Android will not destroy it for you, unless it runs out of the space, and so it won't do it. So when you test it, you will never run into that. You need this very rare coincidence of the user, you know, doing something else while your app was left in this particular state. Okay, so this is an incredibly typical mistake. It's worth knowing. It's, I think, very common. It's all these crashes that happen when you reopen your phone and reopen the app. They're basically caused by you know, you waking up in an activity that you didn't expect to be the initial activity, and doing the initializations wrong. Okay, so there are various solutions to these. Okay, I don't know which one is the best one. Typically, what I try to do is that I try to put a lot of these initializations of the appinfo object, if I can at all, I put them inside the getInstance method, so that when I say getInstance, I actually don't get you know, an empty instance, but the instance tries to fill itself as much as it can. Okay, this is a very safe solution, because essentially then when you get an instance, it contains everything you want. It's not always so simple, you know. Because you know, sometimes the data. I mean, you know, assume that in activity 1 you have created some, I don't know, some message shell. You pass it to activity 2, and so in activity 2 you sort of believe that that message should be there. At some point, you know, the only thing that I know is to be very careful and manually check that these pointers are not null. I mean, it depends a little bit on the context.
Earlier you were saying that you most methods were looking at an activity stack with great
So say it again, sorry?
Earlier you were saying it wasn't a better way to activity for a stack, but to create another instance of it and exactly that is or again.
So say no. So I didn't. Sorry, I don't hear very well what you say. One of the best ways to remove an activity from the stack is to.
You said that creating a different instance and checking the static movie that class to check if it has already been initialized, so that you
Okay. So in a appinfo getInstance, I would check whether it has been already initialized.
Yeah. So would that stop it from crashing?
Well, no, because I mean sometimes the real problem is that if you're in activity 2, you may not know how to initialize it. I mean, if you're relying on user input from activity 1 and now that input has been lost, so I mean, there are various ways. Sometimes, I mean, I haven't had to do this, but at some point I was considering that if activity 2 grabbed one of those objects that was empty and not properly initialized, then I would actually give up and say, and you know, go to activity 1 with a flag clear top, so that essentially I would reopen the app, but on its main screen, not on the screen that used to be open. I think for the users would be a funny behavior in some ways, but you know, if an hour went by, it may be quite reasonable. It's like you're back to Gmail, but you're not in the compose screen, you're in the main screen. Would you remember? Maybe not. Maybe it's obvious. Sorry? Yeah. And so it's done essentially to ensure that if you have to reconstruct the things, you reconstruct them from a sane state. Okay. So yes. So this is one of the various troubles. Now, so this was really not necessarily the question of the student, but things that I think were in preparation with that or related to that. Now, the questions I got are about services, and what's the relation between a service and the activities, and how do the threads work, and by the way, also how do the sensors work? Okay, so what are you doing when you have a service? When you have a service, you are always in the same namespace. So the service is part of the same process, and in fact, as we have seen, you can call from the activity, I mean, you can define this binder that you return, but you can call the binder, and the binder can call methods of the service itself. So again, you're inside the same process. So if you don't do anything special, the service runs in the same thread as the activities, so in the UI thread, right? That is why in the examples I gave you last time, I told you that one of the first things to do was to define a thread that would run the runnable that really contains a sort of the body of the process. Okay? So some of the question, one of the questions I got was, why would you ever use a service? I mean, what does a service give you compared to a thread? In fact, if you want to run a separate thread in an activity, we saw that there are basically two ways of doing it. I mean, there may be more, but there are two common ways. One is essentially a shortcut, which is using a sync task, this class that I described that enables you to do this computation that can give you regular updates and then finishes. Okay, so that's a beautiful thing. And I told you, however, that I ran into problems myself, and I read about problems on Stack Overflow on some particular fonts, because in some fonts they decided that the implementation of a sync thread would have a limited thread pool. And so, if you're assuming that you can have many of these async tasks in parallel, you can get into trouble. In general, the number that I was able to run without trouble is 1. But sometimes when I try to have 2, they would not be executed in parallel. The one was run when the other one would terminate. Okay, so async task is one way, and also you can create explicitly a thread, right? Even here, for example, I did it in an app that has to upload a lot of very small things. You see, I tried to use many async tasks, but this wouldn't really work well. So what I did is instead, I defined my own thread pool. I simply defined, an array of threads of type thread. And when I needed a new thread, I would create a new thread object that would, just as you do for a service. So the code is very similar, but you define a new thread and you start it running a certain runnable. Okay, you can do that. So what's the implication of doing that, of running a thread in an activity? It works perfectly. It works perfectly, but the trouble is that when the activity object is deallocated, the thread is not automatically killed by Android. Okay? So it remains running. It remains running, and not only, but the nasty part is that you have lost references to it. So it's not that when the activity wakes up again, you can say, hey, let me bind to it again or find a reference to it. No, essentially it becomes a zombie. I think that's the technical name of threads. I think zombies for processes actually in Unix, but here we have a sort of zombie thread, because you can't really do anything with it. Zombie threads are a big trouble actually. I told you an instance in which it's particularly easy to create a zombie thread. No, you have a web view, and you start JavaScript. So you enable JavaScript on the thread view. JavaScript is taking a lot of time computing in the web view. Okay. And JavaScript does not run in the UI thread. It runs in another thread, okay, in the browser, in the web view. So if you, at that point, close the activity, the thread that is running JavaScript continues to run and drain your battery, okay? It's very common. And in fact, if you go back in time, you can remember that in the class in which I did the web view, I did that special code in order to stop it, okay? And that's actually important. Okay, so it really happens that this drains your battery if you're not careful. So the main problem, threads in activities run perfectly. You don't need to kill them to the millisecond after you leave the activity. Okay, it's enough to set that you cannot destroy a thread. The only thing you can do is set a flag to it that it tells you next time the thread checks, it should check periodically, and when it sees that flag, it has to finish. Right, that's the way to kill a thread. So it doesn't matter really if it goes on 5 seconds more, or even 30 seconds more. In some code that I wrote, because these threads do an HTTP upload, it can be that if the network is down, they stay 30 seconds trying to do the upload, then they fail, they want to try one more time, they see the flag that tells them to terminate, and they say, okay, fine, I terminate. And nothing happens bad, I will find this is running for 30 extra seconds on your phone. It's a bit non-intuitive to the user, but the user will never know it, and you don't drain the battery because it's only 30 seconds. Okay, but the difference between this and running a thread inside a service is that a service gives you a way to keep a persistent reference to that thread, like in the example we did in class. I don't want to hear you do all the examples we did in class, but so if you want me to represent the code, I'm very happy to do it. But I just wanted to use this time a moment to give you a sort of high-level presentation. So when you are in a service, what do you do? I forgot how it is called, on start, I think, there is an on start and on bind. But when you are in these methods, what you do is that you start the thread and keep it running. But you keep a reference to it in the service. Now, this is not much help, except that if you are in an activity, you can send this intent to the service that says intent bind. This all seems incredibly cumbersome because you say, hey, look, this is just, I'm here, I just created this service. Why do I need to use an intent to bind to it? It's like, hey, too complicated. But no, instead, there is a very good reason. Activities, remember, can be destroyed. So you are in this activity, you started the service, then maybe poof, the activity is removed. Then it's recreated. At this point, when the activity is recreated, it can use the intent bind to bind to the same instance of the service that was created. Okay? And at that point, it can get hold of the thread via the binder, as we did in class. So essentially, some of the purpose of what's the purpose of running the thread inside a service? It's not really to let it run forever, because if you just want to let it run forever in a wild way, you actually can. But the purpose is really to let it run in such a way that you can find it again. Okay, and you can controllably stop it and give control to the user. So that's essentially the goal of the service. I mean, of this structure. Okay. So so this was one of the other things I wanted to clarify. Now, there were two more things I should not forget. I'm very good at making long lists, and then when I talk about an issue, I forget all the following ones. But there were two additional things that I want to mention. One is a detail about sensors that actually was found by the student, by you, right? So essentially, he discovered something that I didn't know because I was reading the documentation in a careless way. When you register a listener, okay, the listener calls you back, but there is a problem. I think here I can erase it. I mean, it's not a problem, but essentially you register a listener and you register an entire class, okay? And this class has a method that says on sensor event. On sensor event or on sensor changed? I forgot which one of the two. Sorry? On sensor changed, yes. Sorry? Maybe? I forgot the name, but it's the one in which you receive the event, right, and it's passed to you. Because there are two of them. One is on sensor changed, and the other one is, you know, these events of the sensor going up or down. There are a few callbacks, but this is most useful. So what happens is this. Okay, the real problem, and then you do now. Actually, I think at this point I can erase this, so I can do that part a little bit magnified because it's interesting. It's really quite interesting. So this is an activity, and the activity is a class, but you can say that it implements, this implements sensor, I can't it is called sensor callback, or event callback, I think. Yeah. Can you fill me in, or do I need to look at the code? Event callback or sensor callback? Event callback. It's the interface that says that you have to have a method that says on sensor changed. Okay, so this implements event callback. Okay. Sorry, yeah, these names I sometimes for they're arbitrary. So inside here you have I forgot what it is, but it's sort of a void on sensor changed. And this gets essentially an event. Maybe it gets also something else, but essentially that's it, okay? And so it has to do something. Now, if you do this, you can do this in any place, okay? So not only an activity can implement an event callback, but the subtle point is this. This on sensor changed will be called in the UI thread, okay? Why? And how is it called? And what's happening? So you remember this notion of the looper. Okay, the looper is essentially this queue. A looper is a queue that can contain two types of things. It can contain either messages, as we are using in the service example, or it can contain runnables. Okay, so what happens, I believe, because I haven't read the source code, but my explanation is in accordance with the facts. So please just imagine as if this were the truth. If it's not the truth is equivalent, okay? So it's like physics, in which when something is complicated, you make a simple model of it. But the simple model is this. When the sensor has some data, it builds a runnable that will call on sensor changed, and it puts it to the looper of the main thread. Okay? And this, will trigger this. Okay? And this is perfect if we are trying to display the value of the sensor, we use it from the activity, because in this way it's executed in the UI thread, and you don't have any particular, risk of getting into trouble with concurrency issues. The problem is that in the service, we didn't actually want to read the sensor in the UI thread. Okay? So there is another way of reading it. If you look at the documentation, you can create, if you are in another thread, if you are in the run method of a thread, okay, you can initialize the looper. I think we looked at the code last time. Do you have the code in a simple way that we can show to people, or do I? Yes. let me see if I can find here a reference a moment. But essentially, initialize looper Android looper. I think it maybe this because the code is always the same. Okay, so here is the example. I think this is so here you are inside the run method of a thread. Okay, so this looper thread is an extends thread, but this can be the thread of your service as well. Okay, so this is a thread of your service. Here is there is a run method, okay, or it's a runnable, but it has a run method. In the run method, you say looper prepare, which essentially creates, I don't know what it does, but it must be creating these data structures for the keyword or something like that. And then you get a new handler, okay? In the new handler, you can define how to process messages. If you just want to process sensor readings, you don't need to process messages. We defined a way to process messages, if you remember, in the service, no, when we were passing these values from the service to activity. Then we have to define a way to process messages. But forget about way to process messages. That is, leave this open brace and close brace without any code in between, and you do a looper loop. Okay, looper loop starts actually the processing of the looper. Okay. At this point, what you do is that you have grabbed a handler object. This handler is the place where you can enqueue stuff into the looper. Now it's like the reference where you can throw in randomables. Now, when you register the sensor, you have to register the sensor using that handler. And in that way, the sensor values will be processed not in the UI thread, but in the thread to which that handler aims. Okay? It's it's too complicated. Let me a moment. How it is called the method to register events? Android sensor register. I'm sorry, I have this bad memory for these for the names of the call of these calls. Okay, but okay, register listener. Okay, so let's look at the documentation for register listener. Maybe it was here. Sorry, maybe it was simply down here below. Register. Yeah, it's probably just below. Ah, yeah, all the methods are here. So register listener can get. I'm sorry that this is you know, Chrome is not understanding. Maybe it's because I don't know. But essentially, register listener, you know, has many methods. But for example, this method, you see that it takes a handler. So that's a way for you to specify that you are registering that piece of code, but that it should be run in the thread to which that handler is aiming. Okay? So if you actually want to read your sensors in another thread, or in the thread of the service, that's what you have to do. This is actually important for the homework, as we realize. Actually, does anybody know what happens if you try to process the events in the main thread? I think what happens is that if you kill the main UI thread, then the process, I don't know actually. It might. I don't know. But I'm not exactly sure what it does. It might work. it's a weird thing to do because the main thread may be used by some other activity. So I don't know whether you get some kind of exception saying that you are trying to execute in the UI. I mean, as soon as you launch your process, then you close your app and open another app. Now the UI thread is busy with the other app. So it would be quite funny that you're able to have it process the sensor readings for your app. Okay? So I would assume that it causes some kind of error. Can anyone confirm what happens? Nobody has had any problems doing it. Sorry? Okay. Yeah, but did you get that? Does your app work even if you like close the app and let it run in the background, get the service, and then run something else and then reopen it? Yeah, try it a moment because you know it might work, but it's a bit of a weird thing to do. And one should verify via the logcat that actually the sensor is being read in the thread of the service. You know that the logcat, when you monitor your app, your thread running, it prints these thread IDs all the time. And you should be able to check actually that this thread ID in which the sensor is being processed, to put a log.i statement in the sensor processing, okay? But you should be able to verify that the thread ID is the thread ID of the service, not the one of the UI thread. Okay, and you verify and it works once you do the handler in this way, right? Yeah, yeah. So I'll write up tonight a better explanation of this, putting together what I'm telling you, okay? But essentially, this is important and is very useful to know. Now, another excellent question I was asked is the following. For instance, in the homework, you know, we're using a looper, via messages, a looper in the main thread to send messages from the service to the activity. Essentially, the path was, so this is separate, you know, from this, but the path was something like this. You had the activity, and you had the service, okay, that is nothing happens, but you had the thread of the service, okay. The thread was calling this method that was called, that was like, you know, you could register, the activity would register, and then you would say this result callback, I think it was called, okay? But result callback would call back the activity. And then the activity would do this very weird thing, apparently, would build a message to itself, okay? It was getting the looper, building the message to itself and sending. Would you like to see the code of that or not? You want to see the code? Yeah. Okay. Yeah, yeah. Also for the people who are, yeah. Let me just find it. It's here. It just one second. It's here. It's here. So in the service task, you have at some point this piece of code that says for result callback. So for all the listeners, I say result callback on result ready, and I give it the result. So okay, so this is the callback that happens in the thread, service thread. Then this calls actually a method in main activity where you do this following apparently extremely weird thing, okay? Where you say on result method ready, okay, this was the method at which the code connected, okay? So what do? Well, you do a log, but then essentially you get the UI handler. So you get, essentially think of the handler as the guardian of the queue of what should be running on the UI thread, okay? You get this, you get this queue of stuff that should be run on the UI thread, and you're putting in it a message. You could also put in it a runnable, actually, but in this case, we are putting in it a message, okay? And the message is actually received here. So one question was, so there are two questions, I think. One is, why are we doing this? And the second question is whether this is too complicated. But let me get to these questions a bit in detail, okay? So the first question is, why are we doing this instead of simply calling back, okay? We are doing this because in the service we have in the service thread. We want this message to modify the UI of the activity. And so in the end, we must, from the service, affect the activity. There are various ways of doing this, okay? One way is to send a message to the activity. Okay, so when this code is run, as I noted in a comment, when this onResultReady is run, you're still in the thread of the service. Now you're putting a message in the queue of the activity, and when the message is processed, it will be run in the thread of the activity. Okay? You could also have done it in another way. So maybe this solution is slightly over complex. Okay? What you could have done is this. In the service itself, if you wish, you could have packaged a runnable. This is a runnable is a Java object that extends runnable and that has an implementation of the method run. No, that's what a runnable is. You could have packaged the runnable, and you could have given it, instead of a result, you could have given a runnable to this onResultReady. You could have gotten, instead of a service result, you could have gotten a runnable, you know, runnable result, I guess. Okay? And then you would have needed here, instead of sending a message, you would have used the MUI handler. There is another method, okay, which says MUI handler, and I forgot the method, but it's something like put or dispatch something, but it takes a runnable as argument. Okay, post, essentially. Post and post delayed. And you have various versions of post according to the delay in which you want to run it. But essentially, you post a runnable to the queue, and then it eventually runs. Okay? That would have been also a perfect solution. Okay, with it. So essentially, we are trying to communicate from the service thread to the UI thread. We create something in one thread, but we want it to be run in the other. And so the way in which you move this running activity, you know, the way in which you can pass the baton in a way from one running thing to the other, typically is by either creating a message or a runnable that you post in the looper of the receiving thread. Okay? Happy with it? Yeah?
I have a question about the services class. So,
yes, let me just, okay, yes?
So the services class is a block two that you use later on in this program to convert your result into a string function.
Yes, I mean, it's a super stupid class, right? It's just a container for an integer. You're saying, why do I use it? I use it because I wanted to be, when I give you these code samples, I try to give you general code that you can adapt to whatever purpose you have. Generally, if you have a service, you may not only want to return an integer. You may want to return, you know, a song composed of the title, a bitmap of the art of the artist, you know. So I wanted to show you how to pass more complicated data types than a simple integer. Okay?
So are we free to say a variable type of our own adapter?
Absolutely, absolutely. Now, I received also an incredibly interesting variation of this question. So, you know, one question, I mean, this was not really asked. I'm going over it again. Why do I do it in this way? But the extremely interesting question, I find at least, was the following. Why do I use loopers and message queues? Loopers and message queues are a method of inter-process communication, but here you are in the same process. Why don't you use something much simpler, was the question. Okay? And this is an extremely good question. So in fact, oftentimes, if you need to communicate simple data types, or if you need to change values in the other thread, we are not using this complication of messages and randoms, right? In this case, it's a little bit too complicated, but if all I needed from the service was to change an integer variable in the main thread, since integer variables can be updated in an atomic way, if I could just update it and there is no consistency requirement with changing something else, assume, I could have just, called a method in the UI thread and toggled the value of the integer to whatever I wanted, right? I didn't need to package a message and do all this. In fact, we use it many other times, in fact, every time we want to tell a thread to finish, we don't bother packaging a message for the thread. We just, toggle a Boolean flag to it, and eventually the thread will check it and will terminate. No? So why in this case we do that? Okay? And the truth is that we're trying to solve two problems. One is to communicate between threads, but the other problem is one of avoiding busy waiting. Imagine that the service produces data at its own pace. Okay? It may be, getting a new fix from the GPS once a second. I think once a second is a typical, for example, speed for a GPS to give you data back, or it might be measuring whatever, but you don't know how often this data is going to arrive, okay? And you want to display as soon as you have it. But if you don't, let's look at what are the simple mechanisms. There is an ugly mechanism that consists in polling. What do? You write your code in the main thread and you say, sleep for 1 second, then ask the service for the value. Sleep for 1 second, then ask the thread for the service for the value. Why is this ugly? Well, because you really get data with a delay. Suppose you are reading the GPS. If the GPS has an update a second, since your polling is not in sync with the new data being available, you have an average delay of half a second additional, right? And also it's just complicated because you cannot sleep in the main thread. And so what are you going to do here? Now you're going to have an async task, so a third thread essentially, that is in charge of mostly sleeping, then every now and then polling the service, and when it finds data via the update method of the async task, will update actually the thing in the UI thread, right? I mean, it's horrible, right? You're creating a new thread for just polling. So, fine, that doesn't work. Now, another solution. How do you solve this problem in operating systems? Let me just unshare the screen so I can focus again on the board. One second, okay? Okay. Yeah? Yeah. Yeah, for the interrupts. Yes, exactly. So what would be another solution? Another solution would be something like this. I tell you how to do it, but I have to tell you I don't remember, or I haven't checked which data structures I should use it to pull it off cleanly. Okay? But what you could do is a variation of this. You could create a synchronized queue in Java. Okay? And then you could use it as follows. You would have the synchronized queue, and then you would have essentially something in the main thread to go to sleep on waiting for the queue to contain at least an element. Okay, and then this would be reading from the queue, and the other process would be posting to the queue. And this works well, except that you cannot really go to sleep on the main thread on this. Okay, because the main thread, I mean, the UI thread can never sleep actually. Okay, and even if it could sleep, my experience is that coding a producer-consumer on the basis of low-level semaphores, it's an interesting exercise, but it's not a particularly safe one. I mean, it's very easy to make mistakes. How easy it is to implement producer-consumer queues really depends on the type of semaphores that the OS gives you. Do you only have like Boolean semaphores that are either taken or free? Or do you actually have counting semaphores? I mean, some of you will have studied these in operating systems. But the people who study these in operating systems realize as well that this is, not the code you want to write every day. I mean, you write it once, you really check that it actually works, and then you try to use it, okay? So the reason for using the looper is that the looper gives you essentially a mechanism for holding a queue and avoiding the busy waiting, right? It's true you are always in the same process, but the looper gives you the ability to say that something should be run, then these things that need to be run are queued one after the other, you know, and the UI thread, as soon as it has time, which is usually incredibly soon, because, you know, the UI thread is, most of the time UI thread should not be doing anything, because it should be ready to respond very quickly to events. You know, if the UI thread does not respond within a certain number of milliseconds, I don't remember how many, maybe 200, I forgot, but something of that order. If the UI thread is not ready to respond to something in its looper in 200 milliseconds, you get one of these ANR errors, activity not responding. Okay? And so what you do is from the service, you package something that is runnable or a message, and you post it to the looper of the main thread. That will get executed pretty soon, very soon, in fact. And it gives you a perfect way to avoid busy waiting and calling the methods where, you know, in the other thread when they are available. Okay, so that's essentially, I think, a sort of big sort of missing summary that about inter-thread coordination. Okay, does this help? Is it clearer now how these inter-thread communications work? Yeah. It's yeah, it's complicated. I mean, it's conceptually a little bit involved how this works. But once one gets the hang of it, it makes a lot of sense. I think the main difficulty, or at least I think the main difficulty is that whenever you read an introduction to Android, the concept of activities is very clearly explained. So everybody knows the activity as a. The concept of threads and loopers, even though it's kind of fundamental to the way the thing works, is not really well explained in the foreground. But it becomes very important if you build elaborate apps. Okay. Okay. What time is it? Okay, 1/4. I could begin databases, but it's like it would almost be more fun instead to have some. Would you like to present something about your project? Would anybody like to ask questions or present pieces of the project? Even you don't need to project. You can just talk about difficulties you have or advice you want to get. Can we open the table to anyone who wants?
Yeah,
Is the battle ship? Okay. Okay. Okay.
Currently, the kind of network we get.
Okay.
We want to we thought that it would be a generally good idea to have. I think we're playing about AI. It's very simple to create. It's like an extra screen and all that extra stuff. But we do actually like that.
I don't know. Many apps have this single player mode.
It's also kind of like getting this very common. Like kind of like hang out.
Yeah.
Yeah. So you can make it. It's like really
I mean, yeah, now I give you a super silly answer. The reason I would do it is that it would enable you to test more easily. Because you know, otherwise you have to phones every time, and it's messy. So you can either implement it on the phone itself, or implement it on the server that sort of pretends to be the other player and replies back. But I would definitely have somewhere the ability to mock the other player, because it's just so much easier to test. And then, you know, you can hide it in the final product if you don't want to show it. Yeah. I see. So actually, your app is an interesting example because, you know, I spent some. I think I told you that I was very frustrated with some app in the marketplace to play battleships. I play it often in the car, no, on Bluetooth, and what I not while I drive, when my wife drives. But I found very frustrating that some of these apps you find in the App Store, when you're on Bluetooth and the Bluetooth disconnects, they don't like remember the game, but they just, you know, want to restart it from zero, which is really annoying, especially if you're winning, no? And and so I wanted to write my own version, And I was so I mean the graphics is not so easy for you to implement the drag and drop of the sheets. Maybe if you do it in a simpler way, it is easier. Actually, if you want to talk about drag and drop and how you draw the sheets, I would be interested. What I was also wondering is, how to best choose the information to communicate between one player and the other, in case the messages are lost. I was wondering, but I never did it, I never implemented it, so I don't know whether it works as well as I think. But I thought that the typical message you send to the other player should be something like, that's interesting. Droplets, I mean, the agglomerates of chalk dust that slide due to static electricity, I believe, on the surface of the board. Yeah, it's very, very nice. So I thought of sending essentially, the board is a square, and I thought of encoding every element can be, I think, either water or sheep or what can it be if it's a board? Heat and what else? A mist, no? Okay, this is a way to encode it. So this is a string of 100 bytes. And then you add a byte on whether you have already played or not. No? So it's like 101 bytes. And you send this string to the server. And the idea is that if you send this string, you don't have problems of checking whether your message arrives. You keep sending it. So you send it when the person moves. And then if you could send it periodically every 10 seconds or every 30 seconds. I don't think it matters very much.
Yeah, our problem is to upload when I play each player plays the information. They're going to click on it. They're going to go through a loop to click each other. They're going to still tag it out. You just play the screen where you want to feel for it.
Right, but the point I was getting to is one of synchronization. So let me tell you the point. Let me tell you what I was trying to get to. Okay, so it's the communication protocol that I think was very interesting. Let me tell you my approach, and it may not work well, but I want your comments, okay? So let me draw it in this way. This is a phone 1, and this is a phone 2, okay? So and this is the server on top in the cloud, okay? So here you have the configuration 1, and here you have a configuration 2, for instance. Now this one moves. Sorry, let me call it, A1 as well. Okay, so this moves and goes to C2. What you start doing is that you start sending C2, and you start getting the most up to date. Okay, and so also here, when you play, you get these, and the server sends back the most up to date. So essentially, the thing is very simple. The logic I would have done is as follows: every phone lets you play only if the configuration you have says that you haven't played already. No, then you play and you have played, and you cannot play any longer. This is like stupid and trivial, but let me say it, okay? Then every phone, as soon as you play, but also periodically every 10 seconds or so, uploads to the server the most recent configuration of the phone. Okay? Now the server, because you're sending up state, has a very easy job, because it has to decide out of various configurations that it has what to send back. Okay? And that reconciliation is very easy to do, because you can very easily tell, messages can get out of order in the network, all kind of crazy stuff might happen. But if you get C1 and C2, you very well know, you don't even need a timestamp essentially. You know which one came before and which one came after, right? Because you can detect that a place that used to be water now contains your bullet or something like that, no? So the server has an easy job of simply the server. What it does is that it gets these status updates, builds every time the most current configuration, and sends it back. And the beauty of this is that this is exactly the type of protocol I like. What I like to implement for mobile are these protocols that send state, do a best effort, and resynchronize autonomously, right? Because in this way, you don't need to keep track of all the complication like, have I sent my move already? No? Have I received an acknowledgement? Aside from the fact that I told you that it's impossible to check, no? in general, due to reach consensus on who played last. So instead of trying to do the impossible, you should simply devise this sort of best effort that eventually synchronize. Okay.
We're going to do a two different sessions every day, so where you shot and where you hit, so each player gets to an array relative to their game phase, so we've got two different settings.
Yeah.
Where I want to choose another,
right. No, absolutely. So I mean, I was just saying the general idea, but the implementation, yeah, might make a lot of sense to have two separate. In fact, you're absolutely right. You need to separate.
Yeah, it's too small. We were going to do like a priority, because you wouldn't have very good exactly.
Yeah. 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 No, I think it's an incredibly neat implementation. But how are you implementing the server?
We are that.
Sorry?
We are that.
I see. Yeah, it's almost as if, we should ask if some good server programmer should join you and help. Not me. I could. I don't know if I'm good, but I could. But no, don't look at me. A lot of fun. So do you have questions? Yeah. I mean, you need some way. So either you implement it on the server, if you're handy with the server programming, you can implement it on the server. You can implement a separate process that generates the moves of the other adversary. But since the project is complicated, I would definitely build some kind of test harness that pretends that he will moves even though there is nobody there. Otherwise, how are you going to test the end game? Yeah, you have to play a game each time just to reach the end of it. Yeah, but I think you should build some kind of test harness that.
Have a game for
Yes. Sorry? Yes.
And it's good to use the layout and I was wondering what you suggest if you told that.
Yes. I've wondered the same thing myself. Because so I haven't written this up, okay? And so I was going through my mind as an extremely lazy person, trying to find the laziest possible solutions. So let me tell you the super ugly solutions in order of easiness, okay? One solution that is actually, I mean, that might work fine as far as I know, is the following. You can create buttons. I think I wonder if I have given you this code, and otherwise I should give it to everybody. But let me tell you the following thing. When you create a button, you might believe that the image button is the main button that has an image on it. But I found out something different. I found that if you create a normal button and then you define a background image for it, there is an attribute for background image, you can get something very interesting. Let me draw the difference for you. If you use an image button, then this button has some shadowing, so that it looks really like a 3D button, and here it's more sparkly. And then here it contains the image in a nice sort of, centered way, which is great, but I've rarely seen this used, actually. If you instead take a button and you define the background image, what you get is this. You get a surface that is the shape you want, maybe a rectangle, whatever it is, okay? It is sensitive to touch via an on-click attribute, okay? And you can define the background image yourself, which can be, for example, I don't know, an explosion if it's hit, or maybe, it can be a blue square of water if there is nothing. Now, you could do this, and you could build then a grid of, a 10 by 10 of these buttons. I mean, it's quite laborious to do it, but you could also probably do it programmatically. Now, the really boring thing is this. You need to do this programmatically because you need to attach a different tag to each one of these buttons. Because it's very easy to define an on-click. You would define the same on-click, hopefully, to all these buttons. But when you click one of them, you know, then the click listener needs to be able to tell which button you clicked. Okay? This is what I would call it's not a like the poor person way of implementing this. Okay, I'm not sure it's the best way. It kind of works. Okay, I'm running low on reserve battery. Yeah, that's true actually. Well, you know, if I lose the people on the other end of the broadcast, that's it. Maybe I should stop it actually. Bye.